All right, we're good. Okay, so we'll go through our homework here. So we've got homework problem. Move them down out of the way. We've got a homework problem 2-94. Why is that not working? There we are. 2-94. There we are. So we've got two forces in our flagpole. Got one here along line FAB, one along FAC. We're told their magnitudes, but not their opponents. So FAB or FB is 700 newtons, FC 550 newtons. What we're needing to find is the magnitude, important direction angles of the resultant force. So our approach here, we'll have step one, create some unit position vectors AB and RAC. Position vectors. Then we'll use that and we'll find unit vectors UAB and UAC. That will let us get our forces in the correct direction. Step 3, find FAC and FAB. Excuse me, I put those in the wrong order there, but I think you're following. 4, I'll write compute the resultant magnitude FR. Actually, we'll compute FR first. 5, find the magnitude of FR. And 6, find the coordinate direction angles alpha, beta, gamma. All right, so step 1, we're going to find position vectors, RAB. So we'll take the location of point B, back off according to point A, and get a vector. So in the x direction, we have positive 2 and 0. 2 minus 0, I, plus in the y direction, we have negative 3, plus 0, j. In the z direction, we have 0 at ground level, whatever orange on our y-axis. And then we're subtracting out 6 plus 0 minus 6k. If I simplify that down, we get 2i, 3j, minus 6k. That's RAB. And then RAC, do the same thing for C. Maybe you can do that in your head. That's positive 2. Positive 3. 3i plus this time 2j. Again, we have minus 6k. All right, so we're done with step 1. Now we'll find step 2, our unit vectors. Step 2, UAB. That's going to equal our RAB divided by the magnitude of RAB. So magnitude of RAB equals the square root each of these things squared. 4 plus 9 plus 36. That goes to the square root of 49. As all of you know, is 7. And then for AC, the square root of 9 plus 4 plus 36. Squaring each of these goes to the square root of 49 as well. 7 equals RAC. So then let me scroll down a little bit here. So UAB is going to equal RAB divided by that. So here's our 2 over 7I minus 3 over 7J minus 6 over 7K. That's UAB. And here, I'll put UAC. It's going to equal, see what do we have? 3 over 7I plus 2 over 7J minus 6 over 7K. The other vector. No step 2 there. Now we need to find FAC and FAB. Step 3 over here. FAB and FAC. So if you recall, FAB equals the magnitude of FAB times UAB, vector UAB. So it's a scalar multiplication of a unit vector with the magnitude in that direction. Makes sense. FAB, recall, is 700 newtons. We're going to multiply that by 2 over 7I, 3 over 7J, 6 over 7K. So that's going to equal, nice math working out here. So we're going to divide by 700, 200 I minus 300 J minus 600 K newtons. That's FAB. And FAC I'll put over here on this side. Close it out. It's 560 newtons. Multiply that by 3 over 7I plus 2 over 7, 2 over 7J minus 7K. Again, the math works out pretty well. So 7 out on this side, we have 80 times each of these. That gets us 240 I plus 160 J. 6 times 80 is negative 480 J. All right, so we got those. Come back up, pick our plan here. That's that taken care of. Now you need to find, or we need to add those together. Step 4, FR, the vector is going to equal that plus FAC. So we're just going to add these components together. FR equals 200 plus 240 I plus negative 300 160 J plus negative 600 480 K. Simplify those together. Maybe simplify is not the right word, but do the arithmetic. 440 I minus 140 J minus 1080 K. And I lost my newtons along the way. There we go. Up here. Perfect. So that's our FR. So we got FR taken care of now. So now we're going to find the magnitude of FR in step 5. Go back down to where we got a space. So FR is going to be the square root of all of that. I'll try to leave it right. 5 FR. So FR is going to equal square root of each of these components squared. So we got 440 squared plus negative 140 squared plus negative 1080 squared. Take the whole square root of that. Do the math, and you can find 1175 newtons. In engineering notation, then that would be 117 kilonewtons. If I recall the rule on rounding, 5. Maybe it's, no, I think I'm the wrong rule there. I think it's even, you don't round it out. That's the only difference there. Be a stickler on that. That's one of our answers, 1.18 kilonewtons. And then lastly, go back up here. Where are we at? We found that. And now we just need our coordinate fraction angles, alpha, beta, gamma. So let's see. 6 alpha, beta, gamma. Alpha, if you recall, is cosine inverse of the x component, so 440 over our magnitude. I'm going to keep the 1125 just for resolution here. Goes to 68.0 degrees. That's our alpha. Beta, inverse cosine of negative 140 over 1125. That goes to, what was that? 96.8 degrees. Finally, our gamma, similar inverse cosine, 1080, 1175. That goes to 157 degrees. All right, so let's take another look up at our problem and our plan. There we go. Does that make sense? See, so adding these two together, we expect the vector somewhere between the two of them here. We found an x component. We found a little negative y component. Bigger. We had something that kind of went like that. The resultant vector. And that seems to make sense. So our angles, does that make sense between x-axis and that? We had something like 70 degrees. That makes sense. So we have 70 degrees here. How about between the y-axis and that angle? Close to 90 degrees, a little more than 90 degrees. That makes sense. And then between the z-axis and that angle, we have 157 degrees, which also makes sense. So we'll end that part, and I'll do the other problems on another video.